So if you haven't, this is another related rates problem. Go ahead and try this one yourself. See what sense you can make of it. So pause the video and see what you can do. So hopefully you just didn't wait for me to do it myself, but if you have, oh well. So we know from the first sentence that our cone has a relationship where the radius equals twice the height. And from the second sentence, if the sand is poured at the rate of 20 cubic inches per second. So that's a change in volume. So I know that dV dt, the rate of change of the volume, is equal to 20. How fast is the height changing at the time the height is 2 inches and 6 inches? So what we want to know is dH dt. And at two different cases, one when h is 2 and the other when h is 6. So we'll deal with h is 2 first. So the volume of a cone is 1/3 pi r squared h. And everything in this case is in terms of height and volume, so it's going to be necessary to make that substitution. We know that r equals 2h. So in terms of just the height, if r is equal to 2h, and we square 2h, then the volume of our cone in this case is 1/3, should be 4/3 pi h cubed. So now I have the volume in terms of just the height. So when I take the derivative, I'll know that dV dt is equal to 4 pi h squared times dH dt. And what I want to know is, what is dH dt equal to? And dV dt, we're told, is 20. That will be equal to 4 pi. The height in our first case is 2 times dH dt. When I solve for dH dt, that'll be what? 20/16 pi is dH dt. Or if we simplify it just a bit, dividing that by 4, this will be 5/4 pi dH dt, and this would be, the units on this would be inches per second. Now the second example, the second question, the only thing that's different about the problem in B is that the h is 6. So we can really pick up from this part of problem A, and instead of substituting in 2, we would substitute in 6. So our work would be 20 equals 4 pi times 6 squared times dH dt, and dividing, this would be 5/36 pi, and this is going to be inches per second dH dt. And I know it's inches per second because it's the rate at which the height is changing, and height is in inches, or volume is in inches cubed. So hopefully this is what you got when you try this problem out yourself.